Welcome to the guide on building a cheap and easy satellite downlink antenna. This presentation is based on a handout developed for the AMSAT booth at the 2006 Rochester Hamfest. It aims to provide beginners with all the necessary materials and instructions to build a functional antenna for 440 MHz downlink. This project was created to help non-satellite hams communicate with satellites using a simple and affordable 440 MHz downlink antenna. The design is easy to replicate and doesn't require sophisticated tools or a workshop, making it accessible for beginners. The materials required for this project are minimal and inexpensive. Foam board and double-sided tape form the main structure, while wire-to-wire connectors are used for assembling the components. Basic hand tools will be sufficient for the entire process. Start by reading through the entire set of instructions to understand the process. Gather all the materials and tools mentioned. Begin by liberating two wire-to-wire connectors from the terminal strip and assembling them to form a complete connection. Accurately measuring and marking the foam board is crucial. Use a combination square and a pencil to ensure precise cuts. Cut the foam board into strips and laminate them with double-sided tape to reinforce the structure. Start by positioning the side panels against the core and marking the positions for the wire elements. Carefully insert the wire elements through the marked positions. Finally, attach the coaxial cable to complete the antenna assembly. The materials listed here are fundamental for constructing the antenna. Each item has a specific purpose, from providing the structural base to ensuring proper electrical connections. Be sure to source these materials from reliable suppliers to maintain the integrity of the antenna build. The tools listed are essential for accurately measuring, cutting, and assembling the antenna components. Proper use of these tools will ensure that the antenna is built precisely to specifications, which is crucial for optimal performance. The precise positioning and length of each element are critical for the antenna's functionality. Follow these measurements closely to ensure that the antenna can effectively receive and transmit signals. Testing the antenna involves ensuring it is properly aligned with the AO51 satellite. Utilize online tools like Heavens Above to track the satellite's position and timing. Proper testing will confirm the antenna's capability to receive signals accurately. The final setup involves connecting the antenna to a suitable receiver and fine-tuning it for optimal performance. Adjust the antenna's position and use additional equipment like a preamp to enhance signal reception. Regular adjustments may be necessary to maintain the best possible signal quality.